Hi all, welcome to my YouTube channel. In continuation of my previous video where I did policy-based routing using a Cisco router. So I'll be continuing this using Mikrotik routers. So basically, what do we need this PBR for policy-based routing? It is actually used to redirect traffic through packets that meet some certain criteria. You want to redirect them through another exit interface to its destination. So first and foremost, we need to understand that a router makes a forwarding decision based on the destination address and IP packet. For example, if I have several destination routes in this particular router, let me enter this router, for example. Let me just go to that router. So, for example, I have, let me go to IP routes. For example, I have, let me say, a destination of address of 192.168.10.0 slash 30, and the exit interface is 172.16.10.1. Then I have another static route, maybe um, this one is going to a.a.a.8 to Google slash okay, let me not do that. Let me just say 192.168 dot 10.4 slash 30, and the exit interface is 172, which is the next up 17.10.1. So now you can see that these two routes they are active and static interface. This is DST address, this is the gateway. So this particular address, for example, maybe 10.0 slash 30, maybe this is at this is a server located at like a head office in another location, and this is another server located maybe at another branch somewhere else. And now you can see that both of them have different gateways, meaning that if you want to go to this particular address, your exit interface should be this gateway, which is your next up. Now that is what that terms is just trying to say. In summary, that a router makes a forwarding decision based on the destination address in a destination address in an IP packet. Maybe you have a packet, maybe that is not generated from this router, coming from another router, and your router is what it used to get to the next stop. You can choose any of these gateway. And I've already on this particular router, for example, I've assigned to an ISP1 to ISP2, and this is the router I'm into now. I've already assigned an IP address 172.16.10.0/30. There's one on this node, and there's two on this node. There's two on this node. There's one on this node on the 17 subnet. So that is why you see it active. I already assigned those IP address on this router. So since the aim of this program is policy-based routing, so I was taking time to explain how, in brief, in summary, how router makes its forwarding decision. So in former video, I did policy-based routing using Cisco routers, and actually, Mikrotik has their own way of policy-based routing. In fact, several vendors have their way, but the thing is, Cisco might decide to have a different pattern to which it gets to its destination, maybe using the policy-based routing. Uh, Mikrotik might have its own method or way of doing the same policy-based routing. The interest, which is the beginning, might be the same. The approach might be different, but the end result will be the same. So that is just a simple, as in the that's just a simple explanation of it. So Mikrotik has its own way of implementing policy-based routing. And for example, in Cisco router, you make use of for some basic firewall rules. You make use of ACLs, access control list, which is what I use in doing the forming my source and next stop address. And with the extended access list, it's so robust that you can do so many UDP, TCP, and whatsoever you want to do, source and destination address, which is the IP protocols or the transport protocols or whatever thing you want to do with it. That is for the ACL. But with Mikrotik, all those particular things can be done using this firewall. Uh, we have a filter rules here. We have a mango rules to cache packets, and then we have NAT as well. So with ACL, we do all these things. Then so what I just explained, I just did this with an example. So now, what is policy-based routing? So policy-based router allows the for conditional forwarding of packets based on the packet characteristic besides the destination IP address. So you as an admin, you are going to set what you want to achieve with your policy-based routing, and then um, and possibly what you just want to do is we have two ISP here. One is connected on ETA, one is connected on ETA 2. So let me quickly bold this ETA 2 to our ISP 1, ETA 1 to ISP 1, ETA 2 to I ISP ISP 2. I just want to try and make it short, and this is actually the LAN. So the LAN is ETA 3 going to a switch and switch to these two uh, VPCs, to these two PCs. So basically, um, I'll just demonstrate what I mean by that particular definition later on. So let me quickly do a DHCP for these two, for those two devices. I'll now come to what IP. I'll come to route, and then let me remove these two. I just did that for definition of brief definition of how forwarding, but there's more to it anyway because there are also exit interface that are registered as well. So and then what else again? And then if you come to even your route as well, you have the gateway, which is the next hop. And then um, just need to be okay. Let me actually assign a gateway. We have 172.17.10.1. I'll give this guy, okay, let me do 16 because the SP1 is using 16. So 16.10.1. I'm just doing this for clarity. By default, static routes take distance of 1. That is by default until you as administrator want to manipulate that. Then 17.10.1. So I'll give it uh, a distance of a distance of 2. So that will be a backup distance, a backup gateway. So I should have an IP now in this router 8.8.8. I should be reaching a public IP from this router. So of course I am. So before that, let me quickly run a DHCP quickly for those VPCs. I've not assigned an IP address to that. Okay, but I have monitor 3. Let me remove one. Okay, let me just leave 10.1. So monitor 3. So let me just quickly, since this topic is not about DCPs, I will not bother myself about describing. I've done a video on that. Check my previous video, you see something I should add to that. So let me play that so that I'll be able to, those VPCs can reach internet. And since I'm using just one public address, two public address in this case, so I can actually NAT that those IP. So, but what I will do, since I have two ISP, I can just come to interface list. I can even define it already, but let me remove it so that you see what I did. I come to list, and then let me remove. I just created a one, a one underscore lists, and then I came to those. I come to the plus sign. Uh, I assigned ETA one as one of to the list. Then I assigned ETA two to the other list, which is ETA one for ISP1, beta 2 for ISP2. Then I'll now come to firewall because I'm going to make use of that. And my LAN IP here is 192.168.10.0/24. And then the out interface list is if it were only one interface that is going out just to one ISP, I can just specify that here. But since it's a list, two interfaces, I need to specify the one list that I created. And then I'll come to action and then I'm masquerade. When it comes to firewall, I'll explain some of these action parts. So I should have let me okay, no connections yet, but let me just quickly do this thing here. Let me quickly obtain an IP for those VPCs. So DHCP, DHCP. So I have IP here. Let me see if I can ping 8.8.8. I do. So connections will be established on that firewall now. The 8.8, that's translations in the not translations. Let me quickly check the router and go there. So I actually have some of those coming up. This is the last one I did, so it has wiped out anyway. So and then what else again can I do here? Okay, so basically if I come to this PC1, which is let me run a trace route, trace 8.8.8.8. You can see that it is following 16.10.1. Let me come to PC2 as well. Trace 8.8.8. And it's also following ISP1. PC2 is also follow ISP1, and then PC1 is also follow as ISP1. So because on this particular router, the active static route, if I come to IP and if I come to route, the default route, the exit interface, the active one is this one, which is to the ISP, to this ISP1. That is what is active here. So for me to do what we call it, and you also do this thing for load balancing as well. What I want to do here is called policy based routing and load balancing. You can also use it for load balancing as well. So what I need now to do, there are two approach to this, to doing what do we call a policy, what do we call it, policy based routing. From the Mikrotik documentation, it's either you do Mango, Mango rules, Mango rules, and routing table, or you do routing rules and routing table. And by default, if you have these two running on the router, Mango rules and routing table is going to we preside, we take over, we write over this because that is most preferred in the router. So on this particular topic, the one I'll be using is Mango rules and routing table. Why routing rules and routing table you can make use of, it's just a simple kind of firewall rule. If you come to, because I'm using OS version 7, if you come to IP, you come to routing, um, where's that? Yes, you come to routing, you come to rules. This is what is basically being described. You understand? You create your source address and destination address, maybe if you are going to 8.8.8, and then you do the, assuming I've created a routing table, let me just create that, but that's not the topic. I just want to show you briefly. I'll come to routing, I'll come to table, I'll create another table. By default, there's only one table, which is this particular table. So I'll create a routing table and I click forward information base because that is what I want to use it for, to forward information, and then apply, and then okay. So if I come to routing rules, the particular IP address I want to IP, sorry, routing, then rules, and then I choose the particular table and I say the source address I want to specify. Maybe assuming I have two of that subnet, maybe .20.0/24, and I say maybe the destination I want it to go is 8.8.8, this particular one. And then if you have the interface you want to specify also, and that's that. But you can use lookup. Lookup is in a sense that if the um, um, what do we call it? If that particular exit interface is not available, it should revert to looking into the main table. But if what do we call it? The if you choose lookup only in the table, what that means is that if that exit interface to that particular destination is down, it should make use of. Let's just do it. Let's see. Let's just do that. Let's confirm so that I'm not using routing map. So I want to go to slash 32. Let's just confirm that. So I'll come to route. Um, Initially I was using .16. So let me apply it on this. I'll come to the table. I already created a routing rule and I apply that here. So so I think that's just what I need. But Mikrotik recommended that for some safety reasons you create another this thing. But let's just run the trace route and confirm that if this take. So you can see now the path has changed from 16. Look at it, even though the distance I put is 2, because I've pointed it now using routing rules. Where's the routing rules? Look at the one I've created. You see? So to this particular destination, you can see. So um it has now changed to 17 instead of 16, even though the 16 is still active and it is on the main table. Let me do that for this as well. You see, it has also changed. Now, what else do I want to show you here? Um, okay, I think that's that, but that's not the aim of this tutorial anyway. So I'm going to return this back to the main and leave it at distance 2. Apply and OK. So let me run the trace route again. Since I've removed the routing rules, it is going to take 16. Okay, it's not even because of the routing rules. I say if it is down. So routing rules. Let me go to my rules. Yes. Because of this option, look up only in the routing table. Let me see. And I specify the address, look up. Let me see. But I'm going to remove that because that's not the topic of today. So I've changed it now. So the path is 1610.0. So because that interface is down, and the option I now choose is look up, not look up only. So initially it was look up only. So it just went down. It did not go through. But now it has chosen this part. So if I do the same thing, that's what it is. So, but meanwhile, let me remove this. That's not the topic of today. The more robust option is what I want to show you. Mango rules, which is this first one here. Mango rules and routing table. That's the more robust option of load balancing and doing your policy based routing. So the same thing is what I did in the last presentation in Cisco. You can choose load balancing with different packets or whatsoever matching criteria you want. Maybe HTTP should go through interface one, and then HTTP traffic goes to interface one, or what do we call it? Every other IP packet should go through interface two, exit interface. So you can do the same thing using Cisco. So, but this is just like I told you, the same interest, different part, different approach, but the same results. That's just what those two guys are, those two vendors are. So I'll quickly remove this. I'll come to use this later on. I'll tell you the reason why I have to use it. So first and foremost, I have to mark packet here. Okay, let me go to DHCP. I want to show you more about it. I'll come to DHCP. I come to leases. So I have one PC1. PC1 obtained 254 PC2 obtained 253. Let me make them static because I don't want the IP to change along the line. So I'll use it to on address lists. Address list, I'll call this guy for PC1, I'll call it La1, and I call this guy address list, I'll call it La2. So if I come to address list, I will have these things are specified dynamically here. So I come to Mango rules. I will now mark those packets. So I can decide to say, now this is the chain I'm going to use. Pre-routing is what I'll be using, meaning that because there are several other options: forward, input, output, post routing, and pre-routing. Post routing after the routing decisions have been taken by the router, it is going out of the interface. Pre-routing before it is pre-routed, before anything takes place with that particular incoming packet. This action should be taken. The output when it is leaving the router, input when it is coming into the router, forward in between the router and that is coming to the router and going out of the router, or out of the router going out right, just passing through the router. That is what you use. I'll talk about all this later on. So pre-routing is what I'm using before anything takes place with that particular packet. This is what I want to be done. So this is what I want. What I want to be doing is I want to mark it. I want to this Mango rules is used for marking packets. So I use access list. So for the packet one, I'm going to use. I will say this packet one should go through ISP1. I can say, okay, let me not even say, okay, let me know, I don't want to use this packet one. I want to use packet one, which is address list one with protocol TCP. TCP, so that's the matching criteria, TCP. And the destination port, the port I'm going to be accessing with it is going to be 443. Remember, this 443 is for web browser, for secured browser, which is SSL over HTTP, which is HTTP, secured HTTP. So now I'll now say for the unsecured, I specify the port number as well, 80. What has this is the matching criteria I have given to this. What I'm saying is that this particular source address and only match only the TCP IP, which is any browsing any browsing to any browsing thing that particular IP want to do should be mark routing. I will say disable. I will not pass through because I don't want it to go to the next line of action. And I'll choose the routing table. I'll say apply. I'll say apply. So this is not what I want to do, but I'm just showing you the matching criteria. It is up to you. This thing depends on your imagination, what you want to achieve. You understand? But that is not what I want to achieve. What I've just successfully done, because these devices added are not browsers. They are just for trace routes and troubleshooting, for ICMP test only. So, assuming I'm using a browser, all the browsing traffic is going to go through. I'll now come to IP. I'll now come to route. I'll say, let me now specify. I'll now say, okay, I want this particular stuff that I've marked. I want the exit interface to be 172.17.10.1. And on a routing table of this, remember I've marked it to this routing table on firewall, and I'll say apply. What I have successfully done here is that all browsing traffic should go through this particular ISP. And then I'll now come and maybe for the main interface, I'll say 172.16.10.1. Let me just mark this one separately as well for the main table or apply. I can create another table for it anyway if I want to. Let me just create so that you see what I'm doing. Routing tables. Create that table. Routing tables. Okay. Routing table 2. You can give it to a better name, but I'm using these default names. And then I'll come to what? Routing. I'll come to IP, firewall, come to Mango rules, come to Mango rules pre-routing, and now specify source address, whether source address list for LAN 2. Okay. Um, I don't want to give it any matcher. Maybe if I want to give it another matcher, for example, I'll say, let me use, I'm just trying to see what I can do with this. Um, um, I'm just trying to imagine something I want to achieve. Okay, anyway, okay, let me not just specify any matcher, for example, because I can't imagine one now. Assuming I have something, I would have just do that with it. So let me just leave this at this, and I say, okay, this particular, but what I want to achieve earlier on, I will revert to that. And I say, okay, for this particular source address, mark routing, and the routing, mark routing, where's the mark routing? And the routing table is routing table 2. So that's just what it is. I'll now come to IP, I'll come to route, and then this particular one now, and now say, okay, go through this table 2, go through table 2. You can see now the routing table is table 2. I've already marked the traffic with each one. But let me come to this place, because my initial attention, I just only use this to describe whatever it is you want to imagine and achieve. But the destination now has specified the particular interface. So the first one I did earlier on, the first one I did earlier on, using port number, this and this. This is actually what we call policy-based routing. You understand? Then the load balancing comes when you come to IP, you come to route, you assign it to each interface. Maybe you want, you cannot control the traffic that goes per interface. That depends on the users. But what I mean here is that maybe this particular interface, the custom a client should go through this interface, another should go through this interface. So if I should come now to, let me check, I should come now and run a trace route. I specify, if I come to IP, I come to firewall, the address list for those guys are different. So let me see, let me run a trace route. You see that the path for this guy is different, because the IP address that was obtained here is 254, and they had the that's 254, and it is the LA1, and I specified I should go through IP route LA1, which is table 1, it should go through 17. So that is why the exit now is not 17. So I do for PC2. So PC2. All right. So earlier on, I was at the static route assigning the the, the marked tables and then the packets, the criteria I wish to mark. And actually had an interruption, so I had to continue now. So I was working in this router, and this is where I was, and I added those the, the table which I've already marked with IP firewall and this Mango Rouge. So, and I also did confirm to you while I was doing that test, it passed it which it was taking. I mean, since I've already marked it now, so as I've marked it initially, it was 16. I've marked it 17 10.1, and also marked this one as well. Yes, I'm doing a pin test instead of trace route. So I also mark this as well 1610.1, which is about three routing table now in this particular router, because you come to routing, you come to table, you have three routing tables. So actually I can stop at just routing table one, leave the other to go through the other table. But meanwhile, for failover to take place properly, I have to do for the two of them. So this is what I'm now going to do. So now, um, if I should for this, this PC1 254 is taking this part. Now, if for another thing I need to do so that there should be auto failover, I've done the policy based routing so that there should be auto failover in case this part goes down. When I was doing routing, I was using routing rule method. Earlier on, there's an option for lookup. There's also for lookup only. The lookup allows for lookup to the next routing table in case the destination or the exit interface is not available. Then lookup only, even if it is down, that is where it is going to be. So meanwhile, I have to do a backup. This is just like lookup only, meaning if this interface is down, those customers have marked on this interface will remain there. They will not have an exit interface. So I have to do a backup for them, which is auto failover. So now I'll do an auto failover for it. This particular IP, I'll just let me just copy. I'll not make it. I will not give it a routing table two. I'll give it routing table two, and I'll give it distance two. I will apply and OK. I'll come to system. I'll copy. I'll give you routing table one. I'll give you distance two as well. Apply and OK. So these are the backup. What I've successfully done is that in case there's any one of those interface goes down, they should pick. Another thing I can also do is to do okay, I've enabled it, check gateway. Also for this, check gateway. So those ones you automatically take. So let's quickly just demonstrate that. Let me pause this interface, this particular one. The IP is 253. This particular PC2 was taking this particular part from this PC2. If we check 16.1, which is this subnet on this particular part. So let us go into that route and see what is happening. I've already disconnected from room 1. I've disconnected from room 1. Let me declare this issue. Advanced copy address. This is just a bonus. At least you get to know how to clear that rumor. So I have to remove this. Let me close this first. I have to remove this. So that rumor have access with it. It's because that was the part I used for the rumor. So it disconnected me. So I've closed that. So let me launch it again. So now I have my rumor coming up. So let me right click and let me use room one again. I will not have access to that router using ISP1. I'll use ISP2 because that's the part that was short earlier on. So let me use ISP2 as well. So let me log into our one. So for look at it now, it is showing unreachable static hardware offload and all that. And the one that is now active is 17. 17. Remember, this is table 2, table 1. So automatically, those address now, those clients on that 17 are supposed to use this table 1. They're supposed to use, what is that table? This table 2 are supposed to use 16 as exit. We now use 17 now as exit because I did it as a backup. So let's just quickly go do a trace route for PC1, PC2, okay, PC2, which is 16 subnet, 172.16. So let me take this through this part. So it will now change to this part because of the backup I did for it. So let's run. So now look at it now. It has gone through 17. Why 17 still remains the same? I can actually still confirm with this, but let me log out of that Roman so that I don't have issue with Roman again. So let me unpause. And that check gateway was what enabled this to be easily captured. So let me now pause this. After about 10 ICMP test or so, um, there will be a timeout. So let me go through PC1. So now the gateway all of them are going to be using is going to be 16. So I will log in. It is for redundancy purpose. So I'll log into arrow 1. So after a while, I should see. So look at it now. It has gone disabled. Why these other ones are not active? If I go to my trace route and I run that trace route, the path now is going to change. All the two of them will take this path. It will take those 16 parts. So look at it now. 172 1610.1 PC2 also 172 1610.1. So let me now enable this. I think I need to log out. I don't want to run one issue again. Resume and then let me log back. Let me log back in and everything now is going to be restored according to the markings. So all the so these two now is now going to be according to the markings. So if I should now run the trace route now, it's expected that PC1 should go through 17. Let me run the trace route. And that is what it is. When I run for PC2, it's expected that PC2 should go through 16 because that is the marking I did for it. So PC2 now, which is PC2 now going through this part, this one now going through this part. That is how you do your policy based routing. So let us now go to that router. Additional thing we can do for this router, though we have done auto failover for this, but we have to do another default route for IP address that we didn't mark. Assuming we have another IP address in this router running and we didn't mark them, and we want them to access the internet. Remember, if you come to routing, you come to table, we have let me come routing table, routing tables. Yes, routing tables. We have three routing tables, so we have to create a default route for the main table. And it's also very important because there are some configuration you might want to do, like policy based routing, like sorry, port forwarding. It's actually useful for the main table. So let me just create that as well. So I'll now say 172.16.10.1. This is useful with the use of distance. So I'm going to use 3. Let me now do the same for 17. I'll now say this is going to be 4. It's going to be 4. So all look at it for the main table. For the main table. So this is just how you go about doing policy based routing and auto failover with Mikrotik routers. And what I did here, if you come to IP, you come to firewall, you come to Mango Rouge, I created an address list and I explained to you that the app packets we are only interested on is the source address. The source address being the LAN IP, the customer's IP, which is the PCs. That is what we're interested in. So we are not interested in marking the private address as well because if you come to Mango Rouge, assuming I didn't specify anything here, every other IP is going to be mapped here, every IP. So I have to exclude not public IP address. And ROFC 1918 defined the private IP address that are meant to be used, that are not routable over the internet, which is the ones I specified here. So that is just the extra things to be done. So that is that for policy based routing. and auto failover. So if you find my presentation interesting, I kindly plead that you help me to share. Let those that are interested in routing and switching, or those that are interested in internet work using Cisco Mikrotik router, know my channels. And also, although I've actually had a little complaint from a friend of mine and also a fan, and he said my topic are a little bit too advanced. This particular topic, for example, PBRO, is found in NTCROE in Mikrotik, and policy-based routing in Cisco is in CCNP. So now I'll be talking about introduction into internet work. Henceforth, I will go down a little bit because these are what I've been doing since are for those guys that are already into networking. So let me go down a little bit. Introduction to network, and I would have taken courses on NTCNA purely, CCNA purely, but no, since this is a channel for both NTCNA and CCNA, I will do introduction to network, where I'll be talking about things regarding Mikrotik at the beginner level and also Cisco at the beginner levels. I'll talk about IP subnetting and the ACL, for example, in CCNA, firewall, for example, in Mikrotik, and other Mikrotik things that you need to know. So please share and let people get to know my channel. Thank you and stay blessed. Bye.